Okay, so in this exercise, we're going to spend a lot more time on the solution side. Hopefully, you've had enough background up to this point that you could have gotten through all of the ideas that I talked about in the intro. Hopefully, if you're watching this, you've already coded your entire working solution using the tests that I provided. If not, that's okay. Let's just talk about how I went about writing this. Again, this is just how I did it. You don't have to do it exactly the same way. If you want to write your own tests and create your own solution, it's entirely fine. We have, I'm going to go back to my program here. We have the basic ideas here. I'm going to change this to tic-tac-toe. And change this tic-tac-toe. And we had the board with the default. That was good. We have the cell. The default is going to be none because we're not going to change anything here. Same with the player. It's not going to be anything. But here we can beef this up here. We can do choices is going to be the range. Let's see. The range is going to be from 1 to 10 because 10 is not going to be included. So let's just make sure that works the way I expect. So if I say tic-tac-toe and I say cell is going to be 0, that's going to be invalid. It's going to be rejected right away. Same if I do 10. But if I say cell is 9, that's going to be okay. We still don't have the idea of that cell and player need to be get together or not at all. We're going to take care of that in a second. We're going to do the same thing here with the player. The choices is going to be either an X or an O, and that's it. And so if I try to put here a player of G, whoops, got a typo here, which is always why I write a little bit of code and then run it. Make that go away. Let's try that again. That's going to be rejected. Player of Jack, but sorry, what I meant to say was an X. If I put an X here, it's fine. If I put an O here, it's fine. So both of those are okay. So that handles some basic validation of our input, but we need to do some manual validation too. So here I'm going to say args is equal to that, and then just so I don't forget, whoops, I'm making a mess here. I want to say return args, just so I don't forget to do that. And then here I'm going to go here and I need to do some additional validation. So the first one I show here is making sure that we have both player and cell or not. And so the way I wrote this is using any and all, which are two functions that I really love. So you can go back to some previous chapters where we've talked about any and all, but essentially if we say any of true and false, do you know what that's going to return? It's going to return true because it's true that there's a true value anywhere in this. But if I say all, that's false because it's not true that everything in there is false. Everything has to be true for all to return true. So what I'm doing here is I'm saying if it's true that any of player or cell, so here I'm relying on the truthiness because the default value for player is the empty string, which is falsy, and the default value for cell is none, or maybe you could have put 0 if you wanted, and that's also considered a false value. So if any of these, if any for false and false returns true, and it's not true that both of these things are true, then I want to throw this parser error. It's a fairly elegant way of writing this. So again, if player is true and args cell is true, so if either one of them is true, then I want both of them to be true. And if either of these sides fail, then I want to throw this error. And you notice here that I'm doing this this combination, this reduction here, and then I'm also doing another reduction here by putting an and in between, and I need to negate the all. So this is pretty good. I'm just going to take this here. I think I should be able to copy and paste that. If not, I can grab it from the solution. I'm going to throw parser error here. So if it's true, let's just see if it works. There. So I provided player 0 and it's valid, and I would never get there if I put in a bad value. So as long as I provide a good value like O, then I must provide the cell. And again here, if I provide an invalid value for cell, I don't even get that far. But if I put cell of 1, then that's going to be acceptable. So that's a pretty elegant way of making sure that they're either together or neither of it is available. The other thing is I need to make sure that the board is exactly 9 characters and composed entirely of .x and O. And I hope that right away you thought, that's a regular expression. And so I'm going to copy this. I'm going to pop it into my program. And then I'm going to talk about this regular expression. Let's see. In order to use this, I'm going to need to bring in the regular expression module. So I'm going to say here, import RE. Now, I show a way of doing this in the chapter without using regular expressions. You don't have to. But this, let's break this regular expression down. And I think that actually I have a nice diagram here. The caret here is the beginning of the string. And then I'm creating a character class of .x and O. And then in the brackets here, I'm putting in a length of 9, which says that this can be repeated, any of these characters can be repeated exactly 9 times. So in the past, we've also used star to be 0 or more, and we've used plus to mean 1 or more. Here I'm using 9 to be exactly 9, and then the $ here means the end of the string. So it's saying if we are searching the args.board here, and we're saying find from the beginning of the string only these characters repeated 9 times, and then the end of the string. And so if that fails, if this doesn't return true, then we're going to throw this parser error. And notice here the feedback here where I'm trying to show the user what it is that they're what is the offending value. So if I put in here -b of some garbage here, then we see that fails. If I put in let's see, XXX ... that's the correct characters, but there's not 9 of them. So if I put in another dot and now there's 9 characters, you see that will pass. So we have, I think that we have all of the validation handled now. Let me just go back and double check that. Oh, no, the last thing that we need to check is if the player and the cell are both present, we need to make sure that that cell is not already taken by an X or an O. Obviously, a dot would be okay. So I just use a little Boolean combinations here. If args player, so if there's a true value for args player, and again, I would not have gotten this far if the player wasn't a valid player. So I already know it's either an X or an O. And so if there's a value there for player, and I already know it's valid, and there's a value there for cell, and I already know it's valid because I've already checked those things, then I need to see, is it true that the args board at args cell -1, because the board is still 0 based, 0 index based, but our cell is going to be 1 based. So we need to see if that cell, the value is in the string X or O. And if it is, then we need to throw an error. So let me just add this code. It's going to be parser error. And now I can check this by hand. So let's say that's my board, and I want to take the cell 1 and I want to make it player X, and I see that cell is already taken. That's a lot of code that we've just validated manually. Let's see how we're doing if we run our test suite. See how things are going. So we get the usage, and we get exist and usage. But so it looks like our first test is for it actually printing the default board. So let's do that in the next video.